Good afternoon. I guess the microphone is working. That answers my question. How's everybody doing today? Still awake at the end of the day? Okay, I don't know whether that's a good thing or a bad thing for me. I am in the process of getting over a cold. Hopefully my voice is going to hold out for the whole hour. If I have a coughing fit, don't worry about me. I will be okay. Who here has some idea what they're going to see in this presentation? Couple? Okay. What are some of your preconceived notions? I'm curious because I know that this is something a little bit different than anything that I've seen done before.
Well, I think you're on BSD Now.
Oh, you saw the BSD Now interview? Yeah.
Yeah, I just heard the podcast. And I think what I'm going to be seeing is as you change one section of the pipe, you'll see the output change in real time, just like the same time.
Right, right. So for the recording, he said as the pipeline's changing, you're going to see the output change as you go along, and that's exactly right. And I will do a quick demo early on before I get into all of the other slides, just to give you a sense of that, because I'm sure that people will have curiosity along those lines. So I will just switch to this for a moment and run PipeCut just on its own source file. And I'll load a pipeline that I have saved from before. And so at the bottom of the screen, you'll see that there's a command line with various statements. And as I press the cursor key to move to the next statement, you'll see the changes taking effect in what's displayed on the screen. So it allows you to navigate a pipeline very quickly and do some interesting things with it. There's a whole bunch of other features that I'll get into in more depth, but let me start off by talking a little bit about the project as a whole, why I did this, what I'm trying to accomplish, and where it's going to go from here. But I did want to give you a sense so that if that's not what you're interested in, you can leave early. So my name is David Maxwell. I've been involved with the NetBSD project for a very long time. That's my primary connection to open source, although I know a lot of people from other projects as well, and have interacted with various people, and I've spoken here at Scale several times before, work-related in a prior job. But PipeCut is a project of my own. It's the first open source project that I've started because I had this idea that there wasn't anything out there that did any good to address this particular problem that I had, which was in using the Unix command line, there's this iterative process of saying, I have a data file, I want to do something to it. I take a look at that file. I then run that file through some sort of filter command that's part of Unix. And then I take a look at the output of that. And then once again, I add some new filter command. So I aggregate all of these commands together to get the set of transformations that I'm interested in. But it's a very back and forth process because the way the command line is oriented, you're either looking at the output of the file in more or less, or you're editing on the command line. You're not doing both at the same time. And this makes sense because when the tools were originally created in the late 60s, the performance of computers at the time, the memory available, the I/O speed, all that sort of stuff, was you might have been typing on a teletype and waiting for the printer to run off your output. So it's not surprising that you wouldn't have something dynamically updating on the screen every time you type a single character. But of course, computers have changed a lot since then, and so I realized that there are some things that we could do in the command line environment that would let us take advantage of that power that's available now. So this presentation is listed as being on the sysadmin track in the conference guide. I just wanted to let you know that I will go into a lot of things beyond system administration. Certainly this tool is applicable to system administration and a whole bunch of other things, but I wanted to let you know that I will get into a little bit of the internal details, so just be aware. So as I already said to you, this came about because I wanted an experience that was more interactive. I wanted something that was a little bit more fluid to deal with some of the day-to-day challenges that I have on the command line. And so I started writing a front-end user interface, thinking of VI as a starting point because that's my editor of choice. Hotkey interfaces where press one key, something happens. Don't have to necessarily go into an extended command mode to have something take effect. And as I started doing that, I realized that there was a bit of infrastructure that I needed on the back end. Because in something like VI, you're manipulating a file. And we already have a good concept of what a file is, and bytes and lines. And so tools to do things like delete a line are very straightforward and obvious once you understand what a file is. But when you start thinking about creating a pipeline editor, you don't necessarily even have terms for some of the things that you're doing or some of the operations that might be very useful. So I had to build a little bit of that infrastructure up. And the way that that ends up looking was, you know, through necessity, I realized that what was needed here was an abstract syntax tree representation of the Unix command line. So who here knows what an abstract syntax tree is? Okay. So an abstract syntax tree is a particular data structure. It's a way of representing information. And if you took something like a mathematical equation, you can write that out, you know, in a straight line longhand, or you can build a sort of structure that describes the hierarchy and the relationship between the components in that equation to each other. So if you were to take a look on Wikipedia, you would see a diagram like this. And fortunately, in the case of the Unix command line, the abstract syntax tree is fairly straightforward because pipelines really only go in a linear fashion from the start of the line to the end of the line. You don't have the branching sort of effect right now, and I'll talk about that more further on in the talk. But from what we traditionally do on the command line, unless you use a couple of the more esoteric shells that let you do multiple input and output redirections and sort of ghost buffers and things like that, you probably have, you know, command 1 pipes to command 2, pipes to command 3, pipes to command 4, and that's it. Is there anybody here who does more complicated things than that on the command line? So some, but small portion. Yeah. In which? Tree? Yes. T. Yeah. Yeah, so T allows you to do a little bit of that in that one of your commands is going to have a side effect of potentially outputting to a file as well as passing on to the next command. But think about, if you will, the sort of command pipeline where you say, I can't actually do this as a pipe anymore. I'm going to have to run it into a Perl script because I have to build a little state machine, because even numbered lines have got to be treated differently from odd numbered lines. Whereas if your pipeline had a way of splitting in two, basically, and processing each of those groups of lines differently and then merging them back together again, but currently in the Unix command line, there's no way to express something like that. But this takes us in the direction of being able to do things like that, and that's one of the exciting things about the opportunities that I've thought up as I built this AST representation for the Unix command line, is that I'm really building it first for this front end. I've got a couple of applications to go with that, and then there are more and more things that people are going to be able to do with it on top. So if you think about a traditional Unix shell, your command line is really a big long array of characters, you know, more or less in the order that you type them, not counting any tab expansion. So each character, one at a time, is taking up a byte. When the shells process your command line, they usually store it internally as groups of words or tokens. So if you look at the command line history inside of C shell or the Bourne shell, you'll see that they have these array of words. And it's convenient that it stores the commands that way, because when you call some of the exec system calls to run another program, one of the ways in which you supply the arguments to it is by supplying a list of words. So having it already stored that way inside of the shell makes it very easy. It's already in the right format to go and call out to the system call. So the difference in an abstract syntax tree is that instead of having a list of characters, what you have are attributes. You have facts about the elements that you're looking at. So for example, the du command here, this is a disk usage command. And just that statement could have a whole bunch of facts associated with it. You know, what the list of valid options for it are, different things that it can do, what the format of input it has, what the format of output it has, and so on. And in this particular case, we know that the show us all entries, every individual file is set, and the don't cross mount points option is set as well. And then we're piping that to this sorting command from largest to smallest. So in an AST, every node in your block diagram, like what I had on the slide from Wikipedia, is basically going to be one Unix command with a whole bunch of attributes associated with it, and then the relationship of how it ties to the other commands in your pipeline. And once you have that AST representation, you can use it in a whole bunch of different ways. So you kind of get a bunch of things free or really, really cheap from the fact that you've done this. So I'll give you one example of shortcutting. Now, not that anybody would ever type a command like cat foo sort. But if you had automatically generated code, you might generate something like that sometime. Or you might have something that do the same thing, so it might not be quite as blatant as this example, but you might still have the same case where you have multiple commands that are essentially not adding anything to the processing that you're trying to do on the content, because they're not going to change anything from what the previous command has output. Well, when you have an abstract syntax tree representation of this, you have this change from the command line environment. Because in the command line environment, every command that's running doesn't know anything about what happened before it or what's going to happen after it. So you can think of it kind of like running an obstacle course blindfolded, right? You've dealt with something, but you don't know what's coming next. And that means that you can't make any decisions about how you perform the operation in order to benefit what's coming next. Because there are times when you could avoid doing some work because you know that the next step is going to throw that away anyhow. So in this particular case, if you had an abstract syntax tree representation of this command line, you could prune out the repeated sorts, because it would know that sort produces sorted output and sort won't change input that's already sorted. Okay? And so it would in effect then execute it simply as cat foo pipe sort, or even just sort foo if it understood how it can use a command line argument to the sort command to provide input. Does anybody have any questions about that concept? Yes?
Is this the same kind of thing as the difference between interpreting and compiling your code?
So the question is this the same kind of thing as the difference between interpreting and compiling your code? Not exactly, although there are cases where that might be true. One of the cases that I'll show in PipeCut is that you can use it as a command filter in place of other Unix commands. And depending on how it's running, it could either be just running the external commands that you would have run anyway, or it could be using its own internal representation of those. The difference in ASTs is that if you run a compiler, generating an abstract syntax tree is usually one of the stages in generating what's called an intermediate representation, where the compiler goes from the very human-readable, code language to something that's highly structured and can be processed with an automated program easily, and then generating output that's targeted for the machine code. So, but in order to do this sort of thing, in order to have an abstract syntax tree of all the different Unix commands, you have to create some categorizations of them. So we know we have Unix commands that are filters. They take input, they produce output, they have no side effects to them. We have Unix commands that are user interfaces like VI or Emacs, where you don't generally put them in the middle of a pipeline because they weren't designed to work that way. Not to say that people don't sometimes. Data sources, you have commands that give you information about the system, like PS or LS or syscontrol or what have you, that give you some information that you're going to then start doing something with. So the AST structure needs a way to be able to describe each of those different types of operations, and it has to know what the type of object is, and it has to know all of the attributes of that object. But of course, there are thousands of different Unix utilities. So if I didn't release this code until I had support for every utility that was out there, I would never release this code. So the approach that I took was to start by implementing a couple of common ones like grep and word count and things like that. And then I created a different abstract syntax tree type called a black box, which says, I don't really know the details of what this does, but it's a Unix command, and here's what the Unix command looks like. So I still get the ability to treat it as part of the abstract syntax tree. It just can't do all of the optimizations that it would be able to do if it knew intimately what that operation was. And what I mean by this is that when you have something like what I had a ways back there, when you start out with a du-ax, if you enter that freehand on the command line, and you now want to turn that into an abstract syntax tree representation, you need something to parse that command line, recognize what the du is, perhaps taking into account things like your current path statement so that we know whether this is bin du or some du you have in your home directory, and then what the various arguments to that mean so that I know the context in which du is going to run. That is a whole bunch of work. I have some thoughts about ways that we can make that a little bit easier to do and support a large number of utilities without hand coding everything, but that's not where I am just yet. I just wanted to give you the idea. On the other hand, when you have either a black box representation or a data type specific representation in an AST of one of these, I call them blade elements of the tool set that you're building up, it's very easy to generate the text representation from that. That direction is straightforward. Going the other direction is harder. Yes?
These are commands and then options. Suppose I have a compound command that I very often use with Python, that's git log. Is your parser going to think that git and log are two separate top-level commands?
Right. So the question is, if you have a command like git log, where the log doesn't have a dash, which is sort of Unix tradition to indicate that it's options, how is the parser going to deal with that? So the answer is that the parser would have to know, in the same way that if you've ever used bash or tc shell that have command completion files that you can load, you can type git, press space, hit tab, and you'll get a list of git commands, because it knows that you've typed git, and so the only thing that's valid to type at this point is one of those git top-level commands. So in the same way, a parser that would consume a command line and turn it into an AST would work the same way. It would have to know git then takes certain arguments. That's not the name of a file that git's going to read or something like that. So I think in order to support this effectively for every Unix command, we might have to think about some standards that tool writers could use to basically build in an option that had sort of like a static array inside their program, or a standard command line option that something could call to say, give me the interface for your tool. So rather...
You mentioned these completion files that a lot of tools like Switch, for example, and Bash itself already have.
Yep.
Would you consider consuming them in your pipeline?
Yeah, so the question is, could we potentially take the bash or the TCSH completion files and use them to feed into the building of the parser for this? And that's possibly a way to go. There would still be some manual work there. So part of what I'm thinking is that if there was a way for the tool authors to build in something that produced the parsable format, then it could work automatically for every tool that supported that. Now, if PipeCut is the only thing that wants that information, then there's probably not going to be a huge amount of incentive for people to go and upgrade their tools to add that output. But it's possible that there would be other applications as well. And certainly, if you look at other scripting environments, for example, Microsoft has their PowerShell environment. They have done a few interesting things, like having the ability to transform output using XML and specify individual elements and do certain types of filtering that are hard to do with traditional Unix text utilities. So having a little bit more structure to the data, or being able to specify what format something comes out in, could sometimes be very useful. We're seeing some examples of that. So there's this whole ecosystem of features that emerges when you have this abstract syntax tree representation of the command line. Persistence is one of them, and you saw it, although you probably didn't realize what I was doing because I didn't say as I went on. So when I ran PipeCut in my example, and I have just cat pipecut.c down in the bottom right-hand corner, I'm just going to hit the open square bracket, which is my load command. It's going to ask me for a toolset name. I named my first demo 1. And so I've now loaded from a SQLite database, this toolset of all of these commands. And because there's an abstract syntax tree representation, it's very straightforward to build a SQLite relational structure to store that and be able to load it and save it as needed. So that's one of the things that you can get easily. Transformation is another example. If I'm in here in this pipeline and I say, great, I've built up this tool set, now I want to keep it for use later, but instead of storing it in the database, I'm going to hit the exclamation mark, and now I'll drop out, and I have a shell script ready for me that was just generated by me hitting exclamation mark from the toolset commands that I had in the editor. So at the moment, this only generates shell scripts, but you can imagine that with a little bit of work, it could also write C code, or Perl, or Ruby, or Python, or whatever you like. In some of those cases, if everything that you have is just support for running a black box, then the Perl and C code is not going to be very exciting because it's basically just going to run external programs and set up the pipes to be able to feed information between them. But sometimes that's all you need, is the ability to build an executable for something instead of having a little shell script. So there are times when that is handy. Optimizations, I already talked about the one example. Another example that I mentioned, if you saw my talk at MeetBSD, if you use a Unix command line and you type something like sort pipe to unique-c pipe to sort -nr, so that you're sorting something by frequency, then there's an inefficiency in that we kind of take for granted, because most of the time the size of data sets that we're dealing with, it's not really a problem. But the inefficiency there is that the first sort command is reading all of the input from the original data set. It's doing a full n log n sort effort on all of that. It's then outputting every line of that data through the pipeline to the unique command, which is then reading through them and generating just the unique lines of output and adding the count of them, and then outputting that to the next sort command. So one way that you can do that more efficiently, if you know, because you have an AST, you know the sequence of commands, that the only reason you're running the sort is so that the unique will work right, because all of the matching lines have to be grouped together. You can instead write something that uses a hash map and counts in the hash buckets, so that you consume a line, you hash it, you drop it into a bucket, you increment a counter. You do that for all of the lines of input, and that's linear in effort instead of n log n. And then you can simply sort the counted output of the buckets and produce the output. So you've saved all the overhead of consuming the output and generating the output a couple of times in that pipeline. And that's just one example of something that you can do once you know what the entire line looks like. Static analysis is another example, kind of like what I was talking about with the cat foo pipe to sort. You can have something that looks at this programmatically and says, you're doing something here that doesn't make sense, either because it's actually incompatible or because it can be done in a more efficient way, or simply in the case of the sort, it's purely redundant. Code generation, I showed you the example of the shell script. API interfaces. So say I want to write a little C program that generates a shell script, or generates an entry that's going to go into the SQLite database. Well, now I have a set of APIs in libpipecut where I can write a C program, call these various functions in a sequence, and generate a pipeline, and then call another function to say save it into the database, or call another function to say generate a shell script for me, or when there's code transformation to other languages, generate a C program or whatever. So I'll talk about need for other libraries in a moment, because that's on my next slide, to reusable in different contexts. So is anybody here a Postgres user? Couple? So one of the thoughts that I had about Pipecut, Postgres has this feature called external data wrappers, where you can say there's a comma-separated value file on disk, and I want to treat it as if it was a table in my database. But I don't want to go through the process of actually importing it into my database. I just want to assume that it's there and tell the database, whenever I ask for things from this table, just go look at the file and give it to me as if it was a real table. The thing about Postgres is that it only has support out of the box for certain file formats, including comma-separated values, as well as the ability to attach to other database engines and read their tables as if they were native Postgres tables. But suppose you had another file format that you wanted to use with Postgres in this way. That's fine. You would simply have to write a foreign data wrapper that knew how to convert that data into the internal format that Postgres needs. But that sounds hard, because that involves writing code. So instead, you load up Pipecut, you build up a tool set that modifies the file from what you're starting with until it looks like a comma-separated value file. Now you save that in your Pipecut database, and you give it a name for the tool set. And now you go over to Postgres, and you load up the external data wrapper with the extension that I haven't written yet, and say, please apply the following pipecut toolset so that I can treat this file as if it's comma-separated values, as if it's a table in the database. So now you have other applications that can use the work that you're doing in the pipecut editor and reuse that. So you can do things that would have required programming otherwise and make them accessible to people who are just using a Unix utility. With regards to the need for other libraries, one of the things that I realized as I was working on the implementation of this was that when you know more about what the Unix commands are doing, you may also find that you want to understand more about the input and the output data. Because there are some design decisions in the way that pipecut works that you aren't faced with until you have a tool that can do this sort of thing. So I have questions, and I'll give you a list of my open questions at the end and some other examples. But in this particular case, I said, you know, suppose you're writing a tool set, and you know that this tool set is going to work with comma-separated values. As an example, that's what the input is supposed to look like. Well, it might be nice if the tool was able to say, don't allow the tool set to run on something that's not a comma-separated value file. So who here knows the Unix file command? Lots of people know file, okay. And you know the library behind it? Anyone? Magic? libmagic, yes. So libmagic is the utility library that looks at those magic bytes and tells you what the file is. Now the goal of libmagic is to do as little work as possible on the file. It really wants to get in and out of there quickly because it wants to give you an answer and be done. It doesn't want to run for an indeterminate amount of time trying to guess things about the file. But I thought, you know, maybe we need libmoremagic. So that's what I've written. So libmoremagic will take a file and do a little bit more work on it than file would be willing to do. And I chose the name because of a story in the jargon file. Does everybody know the magic and more magic switch story? A couple people. There was a computer at MIT, and somebody one day looked in the back of the case, and there was a switch screwed onto the side of the rack that had two labels on it, magic and more magic. And they looked at the switch, and the wire at the end of it went into the computer, and on the other side there was nothing connected to the switch. So the switch apparently would not actually change what was connected to this wire. So they thought, this is kind of silly. Why does the switch matter? So they flipped it from more magic to magic, and the computer crashed. And you can read the jargon file to read the rest of the story, but I like the reference, so libmoremagic is what I've written. So when you run file on a sample data file, it will come back and say something like this line, which is obviously, because I've named it this way for readability, a comma-separated values file with carriage returns with 3 fields generated by JOT, which count from 1 to 100. The file comes back and says that that is ASCII text, which is absolutely true and almost absolutely useless. So what my more magic does is it uses feature extraction techniques, kind of like what you do in OCR or computer vision, to look at the file, and it says, hey, on this file, every single line has the same number of commas. That's probably a hint. And when I take a look at the data between those commas on each of the lines, I notice that all of the fields are numeric. So this is actually a delimited file with comma-separated values, 3 fields that are all numeric. So now I don't yet know what other tools there might be applications for this kind of technique. So this will be packaged as something that people can use in other applications if there's a reason to. I was kind of surprised that I couldn't find anything like this out there. You know, a lot of times when you think of something in open source, you say, oh, I got this great idea, and you go look and there's 5 of them. And in this case, I didn't find one. So this is something that I've built. Question?
Was there some kind of, like CSVs often will have like hidden commas in one of the fields? Did that throw it off?
Right. So the question is, CSVs might have something like hidden commas in one of the fields. So normally in the CSV, if it's going to be correctly formatted, if there's going to be a comma in the middle of the field, then the field has to be quoted, right? So it can have heuristics to do all of that. At the moment, More Magic is still rudimentary, and I'm not going to release the code just yet. I need to give it a wider variety of sample cases and make sure that it behaves correctly. I've just given it a few looking for fixed length fields and delimited fields with whatever type of delimiter, because I wanted to handle things like password files with colons. So I've got to give it a wider variety of test cases and make sure that it's working well before I publish the code, because right now people would not be very excited by it. But that's in the works. Just a brief digression on something else that I found that I think is very interesting, and I'm going to hook into PipeCut in a way, which is there's this object called an IPython notebook, or it used to be called that because the project has been renamed and is now called Project Jupyter. Has anybody seen this before? So a couple. This is really cool. It's kind of similar to a Mathematica notebook concept, where you're typing commands and you're getting output, and it's storing all of this as a file that you can display on the web, so that somebody can follow sort of the step-by-step process that you went through to achieve a certain goal. So one of my intentions is to build this as an output format in PipeCut, so that if I go into the tool and I start doing something like this, you could have, here's what the content was, here's what the pipeline was, then he went one to the right, then the content looked like this, and so forth. I'm using a string library in both libpipecut and the front end called SZ, which is written by a fellow NetBSD developer named Peter Seebach. It's not very widely known. I went looking for, everybody knows that string handling in C is terrible, right? Like, when you get criticisms of C as a insecure programming language, people are usually primarily talking about buffer overflows, and the bad string handling is problem number one. Why is it null terminated instead of being length counted? So Peter Seebach's SZ library is length counted, and so I'm trying to switch everything in PipeCut to use that internally. I'm only partway done, but I'm happy with what it's doing so far. Because SZ is not available in most of the package systems for various operating systems, I'm just bundling it in with PipeCut for now, and then it can get packaged externally if it becomes in demand from other applications. But I'm happy with what it's been doing for me. So that covers most of the ecosystem stuff. I mentioned the SQLite and the persistence. SQLite to me is sort of the obvious choice. Right now, it saves in a .pipecut.db in your home directory. I already have a feature request from someone sitting in this room to support specifying a different database on the command line, and that will be easy to do. It's probably only a couple minutes worth of work, but being sick for the last week, I've been a little bit slower developing than I would like. So you have the structured data in an AST, and persisting it to the database is straightforward. And one of the things that this allows is, creating macros. So if I'm in here, and by the way, I'll talk a little bit about this as I go, because I know I've just given you a couple of random samplings. So one of the things that I can do here is I can delete individual blades out of this tool set. So I'll just press the delete key once, and you'll see that this egrep of DAMA goes away, and the pipeline just collapses to fill in the space around that. But suppose I wanted to delete some more of these, but I'll keep the egrep of liability. But now I want to load another tool set that I've saved before that I'm going to reuse, but I'm not going to load the whole tool set. I'm going to keep what I have and just append the new part on the end. Except that I've found my first bug. Apparently I've got a regression somewhere where I lost that change. So I can, when I'm in here on the command line, I can type a single quote and then manually type commands to run. But normally I could type a double quote and type the name of a tool set that's been saved in the database, and then it would append onto the end. But apparently I've broken that at the moment. So open questions. Right now, I make the major simplifying assumption that all input comes from a file, because having to deal with all of the different ways that you can get input from other types of things is problematic. If somebody starts with a tail-f something, you've got input that's constantly changing as you go, and every time I go to read it, I'm going to get something different. So the ability to say the source is always a static file object that I'm reading from simplifies the rest of the code right now. And as people play around with this and come up with cases where, hey, I'd really like to be able to do X, that'll be a great example to file in the bug database. You can get to that off the web page and put in a request for any ideas that you have that should be added to the tool. That allows a lot of simplifications so that as I'm building up other capabilities, I don't have to worry about dealing with that part of things. Shells have all sorts of interesting constructs. So they have subshells, they have I/O redirection. One of the things that I can show you is, I keep going back to the same example. Let's pick a different example. So here's something starting with a log file. This was one of the motivations in writing PipeCut in the first place, because grepping through log files is tedious. So if I know that there are certain keywords that I want to get rid of, then I can save those in a tool set so that I can use them again later on. One of the things that you'll notice is that as I keep going to the right through those greps, I'm ending up with fewer and fewer lines displayed on the screen. The reason for that is that one of the efficiencies in the way that PipeCut works is it doesn't run the commands across the entire file. So even if you do this on a file that is gigabytes in size, PipeCut's still going to be very snappy and interactive because it's just dealing with a small cut vertically across the top of the file. One of the things that I'm looking at is either the ability to specify how large you want that cut to be. So if you have lots of RAM and you just want to stick it all in RAM anyway, tell it go ahead and load the whole thing, that's fine, and it'll cache multiple copies because it keeps a cache of what the output is like at each stage in the various blades. Or the ability to have later blades exercise back pressure and tell the earlier blades, I need more data because I'm a sort command. I'm going to take everything you have. So just give it all to me. But in this particular case, if I want to see the rest of this file, I can hit page down, and I will actually get the contents of other places within the file that haven't been grepped out. Or I can hit the pipe symbol and go into your good old favorite less. So I'm actually now running the entire file through the set of commands that I had on the tool set, and I'm in less where I can browse up and down as per normal, just after it's been processed by all of the grep-vs. Shell variables are another thing that are problematic if you get into trying to consume complex pipelines. In some cases, shell variables, depending on your shell of choice, you have to export them for them to be visible to third-party commands. So that means that if you have a shell variable and it's not exported, there's no way for PipeCut to know what the value is. And so that would be problematic. One of the things that I see potentially as a solution to this is that if the maintainers of the various shells like this, when it gets a little bit further along, they could consider building in a binding. So you're sitting in TC shell, and you've typed part of a command line, and you say, well, right now I really want to look at this in PipeCut. So you hit a control character, it flips into PipeCut for you. Because TC shell has all of the internal data structure about the command that you're currently editing, it can hand that off to PipeCut, including all of the variables and anything else that it needs. You work on it in PipeCut for a bit, and then you hit another key and you switch back into the command line shell. So this is one way that there might be tighter integration possibilities and cool functionality. But I have done something in the meantime, which is to do the best that I can of that. So if I type a similar kind of line, let's EMI decode, since that's there, and grep-v get text. So if I do that, I'm reading this file and egrepping out those things. If I now type history and give that as my input to PipeCut, PipeCut is going to get my shell command line history. PipeCut knows that when it receives a pipeline of input, it's expecting shell command line history, so it knows how to parse that, and it will then take the commands that I've typed and put them there on the tool set. So I can go from something that I've started editing on the command line and take it into PipeCut without having to redo it all. That was my goal. Yes, so now I'll do additional demos. Sorry, question first.
Is it possible to use PipeCut on multiple files as a directory?
Is it possible to use it on multiple files? So the multiple files would be like PipeCut and multiple file names?
Yeah, or you can cat like dot star.
Right, so if you did that, would you want it to treat all of those files as one concatenated set of input? Or would you want it to do the same operations on each file, one independently?
I'd like to see an output with all the file names on the left.
Mm-hmm.
And you know how the Grep does it, the Grep star.
Oh, okay. So basically intermingle all of the outputs that way in the order. Okay. Yeah, nobody's made that suggestion before, so I'll think about that. I mean, right now you could just do grep for dot and tell it to produce the file names, output that to a file, and then run PipeCut on that. So there is a workaround way to achieve what you want, but I can see how yours would be convenient. So let's load up one of those tool sets again. Now, what I didn't show you was some of the actual features. So let me talk a little bit about the screen layout of the tool. Obviously, the top part of the screen is the contents of the file that you're looking at, the top portion. I can push page up and page down to go through the file. So if I want to look at it and jump back to the top. At the bottom, I have the command line that's built up, the tool set, as I call it, with the individual blades. And I can cursor left or right through those, and it'll highlight whichever blade that I'm on. It doesn't yet do a good job of wrapping around the screen. I've got to do a bit of design choice to figure out how I'm going to handle really long command lines. It's all doable. It just requires deciding how I want it to behave. So as I do that, I can go back and forth. I can hit backspace to delete the last command, or I can hit delete to delete a command that's in the middle. So those are some of the things that I can do. If I just load that one back up again, because it's good for making an example. In the bottom right-hand corner, you'll see this statement that says status, and then it says no RE, no LA, and cache. So those are three modes that can be toggled on and off. The first is the one at the end is the caching mode, which simply says it's not re-executing the commands every time that I do this. It's just redisplaying the data that's already in the cache. The RE and LA modes do something specific, and they are enhancements to the standard Unix commands. So if I turn on the look-ahead mode, what it's going to do is it's going to say, I'm currently on the first blade. I'm on the cat blade. What I'd like to know is what lines are going to be affected by the next blade coming. Obviously, I can't display that when I'm on the next blade, because if it's a grep-v, those lines will be gone by then. So I'm looking ahead to what's going to happen. So if I cursor to the right, the kernel lines are going to stop being highlighted. They're also going to go away because they're part of the grep-v. And then any lines with DH client are going to be highlighted because that's the next blade down the pipeline. And so forth and so on. Now, if I load the other tool set, I can show you the same thing here, but I've got a regular expression that's not just a simple text string. So liability, damage, and then here I've got lines that start with a space, a star, and a space. So in each of those cases, by the way, implementing this is slightly more annoying than you would think, because there are these evil things called tabs. Tabs change the relationship between the number of characters that you have printed and your position in the line, which means that you have to go and count them manually and figure out where the highlighting is supposed to go. Now, that example is showing you the look-ahead mode. Let me show you the regular expression mode. So I'll turn off the LA and I'll turn on the RE. Not that I can't leave them both on. How did I toggle? Sorry, why don't I show the help screen for a moment? So in this particular case, capital L question mark brings up the help screen. Capital L toggled the look-ahead mode. Capital R toggled the regular expression mode. So where I am here with the regular expression mode turned on, if I say I'm going to exclude certain lines, that, by the way, I'll just go through it again. I'm going to press just the letter X, and I get an exclude statement. I get an egrep-v with the single quote already sitting there for me, so I can just type the expression that I want. Because I'm in regular expression mode, as I start typing, I'm going to highlight just those places that match on the screen. And this regular expression can be as complex as I like. You know, it will deal with all of that. If the regular expression won't compile because you got mismatched parentheses or something like that, then it temporarily won't highlight until you close that and make it a valid regular expression again. And so I can do that with includes, I can do that with excludes. You know, anything that uses a regular expression can take advantage of that functionality. Now, this is where the AST becomes important. In this particular case, when I hit X or when I hit G to include lines, I am telling the pipe-cut front end that I want to generate an AST node that is of type include or exclude, so it knows what it is, and it knows that that's going to be a regular expression that it can highlight in the regular expression mode as I'm typing it. If I'm on the command line and I instead type a single quote, whoops, display glitch, more than a display glitch. Woohoo! Oh, that's history. We'll do this. So if I'm on here and I type single quote, turning on the regular expression mode, and now I type, you know, grep something, it's not going to give me regular expression highlighting because it doesn't know that I'm typing a regular expression at this point. However, what I was talking about before, where if I can teach PipeCut about what the command line formats are for all of the different commands, then it could know that this is a regular expression because I haven't given any options, and the first argument to grep is going to be a regular expression. So it could go ahead and start doing regex for me at this point, but it doesn't do that yet. Yes?
Is that using your own implementation of grep, or is that running the command every time you type an extra?
Right now it is using my own implementation of grep, but from the performance testing that I've done, it looks like it will work if I do it externally through the command as well. So a lot of things in PipeCut, I've started doing an internal implementation because I thought I needed to for speed, and then I found out computers are just fast enough for that now. So I've actually deleted some of the things that I had implementations of before. I've also had some features that I've had to get rid of as I went along. So for example, there was a point in time when I had the tool such that I could hit a key and it would take all of these egrep-v statements and combine them with a pipe in between them and make one egrep-v with the ORD expression. It doesn't do that right now because I've got to re-implement that after some other architectural changes. But the fact that I have this AST where I know, hey, we're excluding line, we're excluding line, we're excluding a line, we can just generate an optimized version of that, which is a single exclusion that includes the ORD expression of all of the regexes. Yep. So the question is, if one of the things in the middle is a black box, and that's very much like what I said, where if I type a single quote and I start typing a line like grep, at that point, all it knows is that I'm creating a black box. So until I or some other contributor does the work to help it understand arbitrary command lines and recognize like this is a regular expression portion of a command line, then no, features like the regular expression highlighting aren't going to work. One of my thoughts as a workaround for that, though, which is a very tiny amount of work, I just haven't done it yet, is to give you a keystroke so that if you're typing a literal command and you're about to start typing a regular expression, you could explicitly say, I'm starting to type a regular expression, turn on regular expression highlighting for what I'm typing right now. And so even though it doesn't know what the command is going to do, it could still give you the highlighting functionality. The highlighting, by the way, both the look ahead and the regular expression highlighting, I think just gives you an example of how much of a performance improvement a tool like this can be over doing it on the command line by hand. Because if you've ever typed a command line and then found that you were missing some of the output you thought you should have, and you have to go back and debug by taking it apart piece by piece and cutting off the elements of the pipeline, running it through more until you figure out, oh, that regular expression doesn't actually match the way that I thought it did because there's a space there instead of a tab or something. this makes it much easier to find that. And one of the things that I thought is that, I mean, you know, at the very least, if nothing else, when I start typing something like, you know, that, and the highlight goes away as soon as I type the K, it's, oh, sorry, that's a C, not a K. I immediately get the feedback of where I've gone wrong. Let's see what else. Yeah, I did have a regression in the code at the moment, so I'm going to run an older version just to load up this tool set because it wasn't working correctly with the newer version. I've got a bug to fix. But this is just an example of some of the other commands that are built in. In some cases, sort, for example, is running as a black box. I don't have it as an implementation inside of PipeCut. I do have a key where you press S, and it'll add a black box that says sort. So it's very easy to write little macros like that so that for common commands, you can make the accessors really quick. And then this just shows a little bit more variety of, you know, the types of things that you could do. So what questions can I answer for you now? We've gone over a lot of different directions of where this tool might go. Now you're probably starting to get some ideas of what might be possible. Please share those ideas.
I'm sure it can handle backticks.
So can it handle backticks, for example? So backticks are kind of like the shell variables and subshells that I mentioned before. It doesn't handle it right now. And certainly one of the complex things in handling advanced shell expressions is that different shells sometimes interpret things in different ways. For example, nesting backticks doesn't work in some shells at all, right? Or having two sets of backticks on a line isn't going to work at all. So there's probably trade-offs to be made there where until I have a really good use case where somebody says this is why I need to be able to do this and this is how it ought to work, I probably just won't bother because usually there are other ways to accomplish the same thing. But with some of what I mentioned about the potential for the abstract syntax tree to fork and remerge, you may not need to use backticks in the same way because you might be able to branch, have a node that actually pulls in the data from the external command and then merges it back in. Yes?
So which shells are compatible with PipeCut?
So there's not really an issue of shell compatibility except for the mode where I showed consuming the command line history. And that works for Bourne shell, bash, TCSH, and CSH. There's really only two formats of command shell history. It just depends on how the time is formatted. So it works with all four of those right now. Everything else, you're really inside of a tool like VI, right? So it really doesn't care what shell you're using or how your shell works. Yes?
So is this all running in N curses?
So the question is this all running in N curses? Yes, this is a curses application. Do you have a particular thought about that, or? Okay. So this is the front end that I've written right now. All of the data manipulation on the back end, it's not perfect yet, but it's supposed to be broken out into functions that don't have any front end side effects to them. So you could build a web-based interface to it if you wanted to, or a GUI application, you know, as a desktop app. That's all doable. Yes.
You have a database that these tool chains are in part of that. How are you discovering them again? I assume you're talking about the usability. I mean, can you name these objects?
Yes. So when I have a command up like this, I can press the close square bracket. It comes up and asks me save tool set as, and I say, you know, demo1, and it creates that entry. And now if I go out and go back in, I can load demo1 and be back where I was.
So you can now copy the database to another machine and have that.
Yes. So right now I haven't built. So the question was, could we copy that database to another machine and use it there? So right now I haven't built any utilities for doing things like listing the set of commands that exist. By the way, I will show you another use case though. So if I cat pipecut.c and I pipe to /pipecut, I'm going to use the dash old and assume it works. Dash T and the name of a tool set. Now PipeCut is just going to act like a filter on the command line So it's going to run through that input. Yeah, it ended with a word count -L, so the number is the only output that we get, but it executed all of those things. So that's one way that you could build up a complicated tool set, save it in the database, and then reuse it in a script, for example. And later on, when I add the options on the command line to let you specify a different location for a database, then you could package that database with something that you're moving around so it could load from there. Alternatively, a suggestion that I've had is to have like a JSON export format to be able to create a document that saves one or more tool sets. And I'm also thinking about the sort of social networking aspect of that. The database right now has a very simple structure to it, but it could have more information. For example, I could tie it in with information like PGP. So Brooks wants to send me a tool set. I already have Brooks' key in my keychain, so I get verification that these commands that he's asking me to run, if I trust Brooks, I'm willing to run them. If I get them from some random guy on the internet, maybe I'm not. Yes?
Have you heard of Drake files? It's like by an LA company, Factual. It's like Makefiles for Shell.
It's called Drake Files?
Yeah, Drake.
No, I haven't heard the name before.
It has like a Makefile-like syntax for storing dash.
Oh, okay. All right, I'll take a look at that. Drake Files, a utility from a company here in LA. Interesting. All right. If there aren't any more questions, I'll be around. Feel free to come and ask me something. Thank you very much for joining me. Oh. I'm going to publish the first version tonight. I did a talk about this at Meet BSD conference in November, where it was very much an early proof of concept. I had a lot of code cleanup to do. It's still not completely done. There's still fixed size buffers in there and stuff like that, but it's at least reasonable at the point that it's at now. I've run it through Clang and stuff. So. So when you look at the help text, it's a little bit misleading because some of the ones that are listed there are just generating black boxes for you, and some of them are using an internal implementation. So, for example, the word count implementation is internal. The grep and the grep-v are internal. The hex dump is not internal. Yeah. Okay. Thank you very much, everybody.